We are Project Vendor. Our goal is to make an alcoholic beverage dispenser. It is aimed at average blue-collar workers for their homes, and it is important that we maintain the functionality of similar products on the market while having a much lower price point. The current market for this type of product has two main competitors, Bartendero and Monsieur. Bartendero has options for the number of drinks that can be stored, ranging from 1 to 15. It is currently sold for about $3,700 for its 15-drink package. It uses peristaltic pumps to deliver the drinks and has customizable drink selections based on the user's input. It comes in a very industrial housing, utilizing aluminum square tubing and stainless steel in the chassis. Monsieur has 8 containers for drinks, is marketed at $4,000, also uses peristaltic pumps to deliver drinks, and comes with pre-built menus and management software for the drinks. It comes in a very sleek and modern design that is great for bars as well as home use. In the first semester of this project, we have accomplished all the documentation necessary for the planning of the project, designed the overall product, as well as made the project website. During the course of the second semester, we will have finished the product, including all intermediate prototypes and sequential proofs of concepts as they are needed. The material for the liquid storage has yet to be decided, as this is critical to the success of the project and needs to have an appropriate amount of time allocated to this. Our self-imposed deadline for a working prototype is by the end of winter break or early spring 2015. This prototype will include the pump system as well as controls for the solenoid valves. This is our proposed schedule. As you can see, this semester we have started researching the delivery methods, such as the peristaltic pump versus pressurized lines with CO2. We tested a hand pump system that we built as a prototype for proof of concept of the pressurized lines. We tested various solenoid valves that we ordered. We tested a pressure regulator that we plan to use on the CO2 tank. We have begun developing the control systems, drink algorithms, and the programming of the product. We have started the control electronics and will continue this over the break to have a working prototype by early spring. Next semester we will continue the mechanical design, fabricate the chassis, and assemble the final product and test its functionality. Here's the relevant coursework for our project. EE computing methods, logic design, and microprocessors were all essential in learning how to program the Raspberry Pi that will be in our product. Electronics 1 as well as Lab 2 were essential in developing the control relays for the solenoid valves. Our plan design must be easy to use for the average working class person with low technical skill. It must be easy to clean. It will operate indoors in high traffic areas such as a kitchen. We hope to integrate some form of refrigeration into the device for perishable liquids to last indefinitely, and the interface will be provided through a panel on the device as well as a web application for remote operation that can be accessed through a user's computer or smartphone. Here is a mock-up of the chassis for our device using Autodesk Inventor. The device will be similar in size to an average coffee maker or Keurig. Since the setup is much like that of a coffee maker, users familiar with using coffee makers will have an easy time using our product. It will be made of Lexan to provide a durable design with a modern look while still being cost effective. The embedded controls of the device will be implemented via Raspberry Pi. CO2 canisters, similar to that of the SodaStream, will be utilized to pressurize the lines. Our proprietary mixing nozzle will be designed for optimum beverage delivery, as well as mixing it in a timely fashion. The power will be supplied from an ATX PC power supply that will sit in the base of the device. The GPIO pins of the RPI will be connected to the solenoid control circuit so that the RPI can send signals to open and close the solenoid valve. A biasing resistor will create a current from the RPI to the NPN transistor's gate. A flyback diode will be used across the solenoid to eliminate the voltage spike seen across an inductive load when its supply voltage is suddenly reversed or removed. A 12-volt supply is required to operate the solenoid valve. A mock-up of the user interface that will be seen on the screen of the device is seen here. Buttons at the top will switch between menu and system screens. The name of the drink will be displayed where it says drink 1 to up to 10. A description of the drink ingredients will be displayed under each drink's name, and the edit button in the bottom right hand corner will be used to open a menu that will allow the user access to add and delete drinks from the menu, as well as create new ones. In the system menu, the user will see a table that will show the contents of each container as well as the capacity of it, displayed in percentages of how empty that bottle is. On the other side of the screen, the user will have access to graphics and analytics related to the machine, as well as providing the user with feedback. So they will be able from here to see how much drinks are consumed over a period of time, as well as drink recommendations as far as what they might like based on what they have had before. Here we see a system diagram that shows that the user can interact with the device via their phone, tablet, or computer, as well as the touchscreen tablet on the device itself. This will send a signal to the solenoid control unit, which will then turn on and off the solenoids in a timing based on what drink is being made. And the power supply needs to power all three of these components. This is a flowchart that describes the program that will run the solenoids as far as when they need to turn on and off and for how long each one needs to turn on. The system waits to see if a drink has been selected. Once one is, it moves to see if the first container is needed. Once that container is needed, it turns on that solenoid and starts a timer. It then checks whether or not the time currently is equal to the time that is required to pour the drink. Once that happens, it ends the timer and turns off that solenoid and then moves on to the next one. It does this until all solenoids have been checked and makes sure that all drinks have been poured into the glass. It then returns back to the start, waits for the next drink to be selected, as well as alerting the system to know that the drink has been finished. Health and safety concerns for the product. Food-grade solenoids, tubing, fittings, and containers must be used at every level of the design to ensure that no contamination happens and no one is poisoned. Ethanol content can cause problems with certain materials, so we need to keep that in mind. We need to make sure that there is a total isolation of the electronics from the liquids, and that all electronics are grounded to the chassis. We also need the flyback diode in the solenoid controlled circuit to make sure that we protect that circuit as well as the Raspberry Pi that will be powering the system. Here are the proposed costs of each component that we foresee needing to buy in the scope of this project. To the right is a diagram showing that as the number of containers increase, the price increases, up to $445 for 15 containers, meaning that we can scale our product up very large as well as making it very small for not a whole lot of price difference. With these proposed costs, we believe that we can make a product that is significantly cheaper than the Monsieur or Bartendra, thus more accessible to the average home user. In summary, our product will have a lower price point than any of our competitors to accommodate the working class. We will use pressurized lines to deliver the drink, which is unique in this market since all of our competitors use peristaltic pumps. We will also have a very simple interface with reconfigurable drink menus that the user can change on the fly to accommodate their individual tastes.